The anomalies of the universe that would make even Einstein laugh. The hole that swallows the logic of physics. Imagine there's a place in space where the laws of physics go on vacation, reality wrinkles like a badly ironed shirt, and time decides it won't work anymore. Yes, we're talking about black holes, those cosmic vacuum cleaners that don't just swallow planets, stars, and light, but also the patience of scientists. Welcome to Mindblowing Space, the only channel where the cosmos has no filter and physics gets along with sarcasm. Subscribe if you want to keep losing faith in what you thought you understood about the universe. Let's start at the epicenter of chaos, the event horizon. This isn't the name of a soap opera, but the point of no return that surrounds a black hole. If you cross it, say goodbye to the outside world, because not even light can escape from there. And the best or worst part is that, from the outside, it looks like time stops. Yep, like elevators when you're in a hurry. According to Einstein's theory, if you watch someone fall into a black hole, you'll see them slow down infinitely until they freeze right at the edge. Kind of like Monday mornings, but with more gravity. But the real cosmic joke is what happens inside. Physicists call that infernal center the singularity. And no, it's not something special, but a mathematical nightmare where density becomes infinite and equations start screaming for help. And what's in there? No one knows. It could be the end of time, a source code point of the universe, or the place where the missing sock from the washer hides. And this is where the great clash of titans comes in, quantum mechanics, which works for the very small, versus general relativity, which explains the very large. Together, they short circuit. One says, everything is indeterminate. The other says, everything is curved. And here we are, in the 21st century, with telescopes that can see the origin of time, and still no idea what the hell happens inside a black hole. The cosmic drama of the radiation that shouldn't exist. There are bad jokes in the universe, and then there's Hawking radiation. It turns out that black holes, those insatiable devourers of matter and hope, aren't as eternal as we once believed. Stephen Hawking, yes, the guy who turned scientific sarcasm into an art form, discovered that these space beasts glow. That's right, they emit radiation. How? Thanks to quantum mechanics, the universe's operating system that no one understands but everyone uses. According to this theory, right at the edge of a black hole, on the event horizon, pairs of quantum particles pop into existence purely on the whim of the vacuum. One falls in, the other escapes. And by escaping, it steals energy from the black hole, which starts to shrink like a wool sweater in the dryer. Yes, the most feared object in the cosmos loses weight. Very inspiring. What's truly chilling is that if a black hole loses energy, it eventually vanishes. It evaporates, like your will to work in August. But that creates a dilemma of cosmic proportions. What happens to all the information that fell in? Because according to physics, information is never destroyed. You can burn a book, shred a hard drive, or delete a folder from your desktop, though it only vanishes from the system, not the universe, thanks for nothing, Windows. But in theory, everything that existed should be able to be reconstructed. So what does the black hole do? Does it swallow the information and spit it out as random radiation? That would be a brutal violation of the laws of physics, worse than forgetting to use your turn signal on a quantum roundabout. This led to one of the biggest scandals in the scientific world, the information paradox. And no, there's no simple solution. Some say the information gets encoded on the event horizon. Others claim it travels to another dimension. And there are those who believe this is all a simulation, and Elon Musk has the password. The universe once again laughing in the faces of physicists. And the physicists, armed with chalkboards in desperation, trying to figure out what the hell is going on. The universe might have no space or time, and that's not a joke. Get ready for one of those ideas that sound like they were written by a sleep-deprived screenwriter with too many cups of coffee. Space and time might not exist, at least, not the way we think. According to a growing and worryingly popular branch of theoretical physics, what we call space-time might be an emergent illusion, like a hologram, but without the special effects. Or worse, like Wi-Fi, it's there, but no one really understands how it works. So, where would space-time emerge from? Not from nothing. From something even more confusing. Quantum entanglement. That absurd property where two particles separated by galactic distances behave as if they're sending each other instant WhatsApps without signal and without antennas. According to this theory, the entire fabric of reality is stitched together by those invisible connections. And yes, that would make the universe a kind of quantum network without a router. This approach, known as emergent spacetime, suggests that the reality we perceive is just a surface level, Beneath it lie more fundamental structures that we still don't understand. As if all of existence were a shadow play projected by a lamp we haven't invented yet. Einstein is rolling in his grave and not from laughter. But if space and time aren't fundamental, then what the hell is? Good question. Some physicists say we might be made of quantum bits that occupy no place and have no duration. Others talk about pure mathematics that encode existence. And then there are those who simply admit they have no idea and hide behind endless equations to keep up appearances. What's truly fascinating is that this line of research is gaining traction. The math works, the experiments partially too. But no one can say for sure if time is an illusion, or if it's just pretending to be linear so we keep showing up late. So the next time you say, "I have no time," you might actually be right. And when someone asks you where you are, the most honest answer might be, in a quantum illusion created by entanglement. Good luck explaining that to the Postal Service. Black holes might be the universe's servers. Imagine that a black hole isn't just a star shredder, but a cosmic filing cabinet of secrets. Yes, like that drawer where you stuff all the papers you don't know whether to toss or keep. Only here we're talking about planets, civilizations, and maybe previous versions of the universe. Because in the universe's latest attempt to mock our logic, it turns out black holes might preserve all the information they swallow. How? Well, that's still being debated in scientific meetings where the anxiety level is only topped by that of Mondays. The concept comes from combining quantum physics with the principles of information conservation. In theory, everything that falls into a black hole from an atom to an overconfident astronaut leaves a quantum fingerprint in the radiation the black hole emits as it evaporates. Meaning, even if it swallows everything, it spits it back out in the form of data, as if the universe had a backup mode enabled since the beginning of time. And if that sounds surreal, wait. Some physicists believe that, with a quantum computer advanced enough, we could reconstruct everything that ever fell into a black hole, from the radiation it emits. Yes, like recreating a pizza from the smell left in an empty box. Only here we're dealing with subatomic particles and the limits of reality. Minor detail. This unexpected twist has opened a path toward what they call quantum gravity theory, the holy grail of physics. A theory that would unite the rules governing the microscopic with those explaining the cosmic. One single law to explain it all. Or at least, to explain why the universe laughs in our face every time we think we've got an answer. And why do these anomalies matter? Because if space and time are just emergent effects, if information is never lost, if black holes are mathematical portals disguised as monsters, then maybe everything we know about the universe is just the surface of something infinitely deeper. And you, who made it this far, are already inside the hole. Not a real one we hope, but inside the greatest mystery of the cosmos, understanding what we are and where all of this came from. Subscribe to Mindblowing Space, where the impossible is just an anomaly with good PR. See you on the next cosmic ride. Kepler 452 billion reals, Earth's muscular and suspiciously warm cousin. A rocky planet 5 times heavier than Earth, with shallow seas, potential jungles, and gravity that could snap Superman's spine in half. Welcome to Kepler 452 billion reals, the planet that looks like it was designed for life, if life were training for the galactic Olympics. It's in the habitable zone, receives slightly more energy than Earth, and to top it off, it orbits a yellow star almost identical to the Sun. Too perfect? Exactly. That's why we're here. Welcome to Mindblown Space, where logic is suspicious and the impossible is just another Tuesday. Today we travel to Kepler 452 billion reals, the world NASA called the most Earth-like, but which hides a few tricks under the carpet of its atmosphere. Located about 1,800 light-years away, this planet was discovered in the year 2015 by the Kepler telescope. It completes a full orbit in 385 days, basically a school calendar with no holidays. Its distance from its star is just over 1 astronomical unit, which means it's exactly where it should be, if it weren't for the fact that its star shines a bit brighter, 10% more, to be precise. The result? An average temperature of 27 degrees Celsius, ideal for a vacation. Or for fast-forwarding the end of the world with an unleashed greenhouse effect, Venus style. And now comes the most absurd detail. Its gravity is more than twice ours. In other words, any attempt to walk becomes a mandatory CrossFit session. Seriously, any hypothetical inhabitants of this place would need steel bones and lungs the size of a cow. But apparently, this helps the planet retain a dense and stable atmosphere. Great. A deadly and constant sauna. And life? According to some models, the shallow seas could host it. Sure, as long as those oceans haven't already evaporated due to an overly enthusiastic atmospheric composition. It all depends on how much greenhouse effect is cooking up there. In short, Kepler 452 billion reals could be paradise or a grill. K2 to 72e, the cozy planet that wants to kill you with solar flares. Let's suppose you loved Kepler 452 billion reals but found it a bit crushing. You're looking for something friendlier, maybe a mild climate, solid ground, a place where you don't have to crawl like a wet rag because of the gravity. Good news, it exists. Bad news, its star is a ticking time bomb with violent outbursts. That's K2 to 72e, the galactic resort with stunning auroras and a decent chance of frying you like a microwave dinner. Located more than 200 light-years away from us, K2 to 72e orbits a calm red dwarf that, like all red dwarfs, is anything but calm. Although modest in size, its bad temper is legendary. The solar flares from this little star are not exactly polite greetings. They can rip off your atmosphere in one go or turn your pretty biosphere into a radioactive field. But not everything is cosmic drama. The planet is within the habitable zone, receives even more energy than Earth, and has an average temperature of 22 degrees Celsius. Perfect for a barbecue, if you manage to survive the stellar wind. Its gravity is a bit stronger, but nothing that a pair of well-evolved legs couldn't handle. It's larger than Earth, has more mass, and probably a dense atmosphere rich in elements. Now comes the mind-blowing part. If its atmosphere manages to withstand the stellar assault, something that would make any hypothetical magnetic field very happy, then the planet could sustain liquid water. And that, in galactic language, translates to, hey, life could show up here. Of course, that life wouldn't look like anything we know. With a different light spectrum and constant radiation bombardment, the plants might have purple or red leaves, and living beings would need tougher adaptations than a cockroach during the apocalypse. Think thick skin, fireproof cellular structures, and resilience that would make any tardigrade cry. K2 to 72e is, without a doubt, one of the strongest candidates for a kind of life that doesn't mind a little atmospheric chaos. A cozy place? Maybe. Safe? Only if you have a lead suit and nerves of steel. Welcome to Mindblowing Space, where logic is suspicious and the impossible is routine. Glies Tenno 2b, a frozen planet with central heating included. 15 light-years from Earth, basically just around the corner, if you're driving at the speed of despair, lies a planet called Glies Tenno 2b. And although its name sounds like a Wi-Fi password, it's one of the most serious candidates for hosting life beyond our little blue world. Of course, only if you enjoy living on a cosmic ice sheet with a view of a tiny star that barely glows. Perfect for people who are always complaining about summer. This planet was discovered in the year 2022 using the radial velocity method, a technique that basically detects when stars get nervous because something with mass is orbiting them. The culprit in this case? Glies Tenno 2b, a rocky planet that orbits so close to a star so small it makes our Sunday look like an influencer addicted to attention. Now, the conditions. It receives less energy than Mars, which means its surface stays at a delightful minus 40 degrees Celsius. A paradise for mutant penguins, suicidal bacteria, or any form of life that enjoys skating on frozen oceans. And yes, I said oceans. Because here comes the mind-blowing part. Scientists believe that despite the polar cold, this planet might have liquid water in its sunlit hemisphere. How is that possible? Thanks to two favorable factors. 1. Tidal locking. The planet always shows the same face to its star, keeping one half warm and the other one terrifying. 2. A potential greenhouse effect that heats things up more than expected. Basically a low-consumption cosmic heater. The gravity is almost identical to Earth's, so walking wouldn't shatter your knees. And its size is so similar that you could build a replica of your house without redesigning the toilet. What we still don't know is whether it has an atmosphere, any geological activity, or if it's just a death trap with a sci-fi series name. Is Glies Tenno 2b humanity's next home? Only if you don't mind ice, darkness, loneliness, and a star that looks more like a candle than a sun. Welcome to Mindblowing Space, where logic is suspicious and the impossible is routine. Glies Tenno 2c, the sibling planet that looks like a freezer, but comes with volcanic surprise. If Glies Tenno 2b seemed cold to you, wait until you meet its sibling, Glies Tenno 2c. This exoplanet is so far from its star you'd think it was exiled for bad behavior. And judging by its surface temperature around minus 90 degrees Celsius, we wouldn't be surprised if the star just couldn't stand it. Still, here we are, talking about it as a possible candidate to host life. Because apparently, in space, having volcanoes under the ice is now considered promising. What a time to be alive. This planet is located a bit farther from the center of the system than its brother, and it takes more than twice as long to complete a full orbit. It receives about 4 times less energy from its star than Earth does from the Sun, which in human terms means freeze, creature. Everything points to its surface being a frozen and inert slab, a cosmic freezer with no off switch. But don't leave just yet. The real show is underground. According to simulations, the core of Gliese 1002c might be active. Very active. And far from being bad news, this opens up the possibility of a subsurface ocean heated by geothermal activity. Lava under the ice, steam in the abyss, and if we throw in some organic chemical compounds, we have every optimistic astrobiologist's favorite scenario. This, by the way, isn't that far-fetched. In our own solar system, we have moons like Europa and Enceladus, where oceans under the ice are suspected to exist thanks to internal heat sources. So if a lost moon can hide hot water and weird molecules, why not an entire planet? Of course, the big issue is still the atmosphere. We don't know if it has one. And if it does, it's probably made of gases unfit even for cockroaches. But that doesn't stop models from insisting that, somewhere in a dark and slimy corner, life, even if it's microscopic, squishy, and totally unglamorous, might be squirming to survive. So there you have it. Gliese 1002c, a freezer with a volcanic soul. A world that seems dead, but might be boiling on the inside. Like a frozen dumpling you microwaved the wrong way. Subscribe to Mindblowing Space if you enjoy these journeys to impossible worlds where ice, lava, and cosmic madness are always on the menu. And leave us a comment. Would you live on one of these planets? See you on the next orbit. This cosmic event could light up the sky like never before. A star that refuses to die. Almost 3,000 light-years from our planet, a binary star system known as T Coronae Borealis is about to put on a show that happens roughly once a century. The explosion this star emits is not a supernova, but it resembles one enough to become one of the most anticipated astronomical phenomena of the year. This event, known as a recurrent nova, occurs when one of the stars in the system, an extremely dense white dwarf, steals matter from its red giant companion until it reaches a pressure and temperature high enough to trigger a nuclear explosion on its surface. What's fascinating is that after this explosion, the star doesn't vanish. It simply dims during another long cycle of matter accumulation, as if the universe is giving it a second chance. This celestial dance has repeated with surprising regularity. The first time it was observed was in the year 1866, when amateur astronomer John Birmingham, walking under the night sky of Ireland, noticed a new star shining in the constellation of Corona Borealis. Since then, astronomers have kept a close watch for every possible reappearance. The most recent outburst occurred in 1946, and scientists believe a new explosion is imminent, probably within the next few months. These types of events, although more frequent than a supernova, are rare enough to inspire awe every time they occur. At its brightest point, the T Coronae Borealis system could match the luminosity of the most visible stars in the night sky, becoming noticeable even without telescopes. Its apparent magnitude will shift from 10 completely invisible to the naked eye to around 2 or 3, making it one of the most prominent stars for a few days. The mechanism that turns a dying star into a celestial spectacle. To understand why T Coronae Borealis, nicknamed the blazing star, behaves this way, it's necessary to delve into the processes that govern the lives of binary stars. This system is composed of 2 celestial bodies orbiting one another, a white dwarf and a red giant. The former is the collapsed core of an old star similar to our Sun, a structure so dense that a teaspoon of its matter would weigh tons. The latter, by contrast, is in the final stage of its life, bloated and constantly losing mass. The gravity of the white dwarf is so intense that it slowly pulls matter from its companion, accumulating a superficial layer of hydrogen. Over time, that layer reaches extreme temperatures and pressures, triggering a thermonuclear reaction on the surface of the white dwarf. This reaction does not destroy the star, but it releases an enormous amount of energy, enough for the system to increase its brightness up to 1,500 times within a matter of hours. This is what is known as a classical nova, a repeatable outburst, as long as the system manages to survive itself. What's most surprising is that, unlike supernovae, classical novae do not involve the definitive death of the star. After each explosion, the white dwarf remains almost intact, ready to begin the process of hydrogen accumulation all over again. It's a kind of stellar resurrection, a continuous cycle of buildup, explosion, and rebirth. This behavior has turned T. Coronae Borealis into a natural laboratory for studying the final stages of stellar evolution and the dynamics of binary stars. During the days when the explosion is visible, thousands of astronomers and skywatchers around the world will point their telescopes toward the Corona Borealis constellation. Even those without specialized equipment will be able to spot this bright point appearing where there was nothing before. It will be a rare opportunity to witness, with your own eyes, the power of stellar physics in action. Why this explosion is a unique opportunity for science. Every nova visible from Earth represents an invaluable opportunity for modern astronomy. T. Coronae Borealis is no exception. While in the past humanity was limited to observing these phenomena with the naked eye and recording them in rudimentary ways, today astronomers have access to space telescopes, advanced spectroscopes, and tracking systems that will allow them to study this explosion with unprecedented detail. This includes the ability to analyze the chemical composition of the expelled material, its expansion speed, and the dynamics of the interaction between the white dwarf and its companion. When the nova occurs, instruments will be ready to capture the first signs of the outburst. The light emitted by the explosion will travel 3,000 light-years before reaching us. This time delay means that, in a sense, we will be witnessing an event that occurred long before human civilizations, as we know them, even existed. The information contained in that light may reveal details about the temperature of the stellar plasma, the presence of elements such as carbon, oxygen, or iron, and the energy distribution across different wavelengths. In addition, observatories will be able to measure emissions in X-rays, ultraviolet, and infrared radiation. This will help to better understand how magnetic fields behave during these explosions and how they interact with the interstellar medium. The study of novae is also key to improving our understanding of more violent events, such as Type Ia supernovae, which do completely destroy the white dwarf and are essential for measuring cosmic distances in the universe. The nova of the blaze star, as it is also known, will serve to test astrophysical models about mass transfer, thermonuclear detonation, and the evolution of binary systems. Scientists hope this event will provide data that help solve an old mystery: when and why a white dwarf transitions from the nova cycle to the supernova stage. Understanding this leap could shed light on the history of many galaxies, including our own. The scientific community is preparing with great enthusiasm, and you can be part of this unique event too. All you have to do is look up at the sky at the right moment and perhaps witness one of the most breathtaking spectacles in the cosmos. How and when you can see the nova with your own eyes. Witnessing a nova with the naked eye is not something that happens every day. For most people, this phenomenon is as rare as seeing a bright comet or a total solar eclipse. That's why the outburst of T. Coronae Borealis represents a historic opportunity. And the best part is, you don't need to be an astronomer or own a telescope to enjoy the show. All it takes is looking up at the sky at the right moment. Although the exact date of the explosion cannot be predicted, astronomers have studied the activity patterns of this binary star for decades. The last time a nova occurred in this system was in the year 1946. Nearly 80 years have passed since then, and everything indicates that the new eruption is about to happen. Experts agree that it will likely take place during the second half of 2024, probably sometime between July and September. When it happens, the blaze star will suddenly increase in brightness. It will go from a magnitude of 10, invisible to the human eye, to a magnitude between 2 and 3, placing it among the brightest stars in the night sky. For comparison, it will shine similarly to Polaris, the North Star. This change will be so dramatic that it may appear as if a new star has been born in the sky, and indeed, that's what many ancient cultures believed when witnessing similar phenomena. To find it, you'll need to locate the Corona Borealis constellation, a semicircle of stars in the northern sky, between the constellations Hercules and Boötes. From hemispheres with clear skies and little light pollution, it will be visible without any technical aid. However, if you do have binoculars or a basic telescope, you'll be able to notice details in the color and the surroundings of the exploding star. The visibility won't last long. Within days, the nova will slowly fade until it disappears once again. That's why it's important to stay alert to astronomical announcements. Various observatories and science media will report in real time when the nova begins. If you want to experience a unique astronomical moment, all you'll need is some patience, a clear sky, and to look where the universe decides to ignite a new, fleeting yet unforgettable light. If you enjoyed this journey through the mysteries of the cosmos, subscribe to Mindblowing Space and join us for every new adventure the stars have in store. 20 astronomical lies you still believe and shouldn't. Zero gravity is space's Santa Claus. Zero gravity in space? Sure, right next to space unicorns and the meteorite fairy. This is one of the most repeated myths in modern history, that up there, floating above Earth, gravity doesn't exist. And although it's true that astronauts seem to float like aimless feathers, that doesn't mean gravity went on vacation. In fact, without it, the International Space Station would fall like toast without butter. Welcome to Mindblowing Space, where we dismantle myths with orbital elegance. If you're ready to lose faith in what you thought you knew about the universe, stick around. The journey has just begun. Zero gravity? That was never zero. They say there's no gravity in space, that you float like a leaf because, well, up there everything is weightless and magical. But no. The reality is that the International Space Station is constantly falling toward Earth. So why doesn't it crash? Because it falls in a curve, as if surfing on gravity. So no, rookie astronaut, there's still gravity. You just float like someone in an elevator with no cable. We never went to the moon, according to your brother-in-law. Another gem of after-dinner critical thinking. That it was staged, that it was a film set, that the flag waves. The truth is, there are retroreflectors on the lunar surface, rocks brought back from the mission, and over 400,000 people involved in the Apollo project. But of course they made all that up too, right? Spoiler, yes we went. A day lasts 24 hours. Sure it does, champ. Nope, a real day lasts 23 hours and 56 minutes. The whole 24 thing is a cultural fix, so the sun is kind of overhead when you have lunch. And to keep the calendar from falling apart like a messed up Excel sheet, we add leap years. So yeah, we live a well-organized lie. We come from monkeys. Well, sort of. Another common mix-up. We don't descend from today's monkeys. Not gorillas, not chimps. We share a common ancestor, but our branches evolved down different paths. And surprise, modern humans are the only ones left in the Homo genus. The rest? Extinct. Kind of like your teenage exes. They were here, but now they're not. The Great Wall of China is visible from space. Just no. They even put it in textbooks, and it's false. From space, the wall blends in like a snake on a velvet couch. It's the same color as the landscape and way too narrow. It's easier to see highways, dams, or the Egyptian pyramids. But the wall? Nope. The solar system isn't just a gang of 9 planets and that's it. Remember when Pluto got kicked out of the Planet Club and everyone cried about it? Well, that's just the beginning. The solar system isn't just 8 or 9 balls spinning around the Sunday. It's a monstrous collection of celestial bodies, gas, ice, rocks, asteroid belts, and an Oort cloud stretching farther than any GPS would dare calculate. Welcome to the real neighborhood. Newton's apple didn't fall on his head. Once again, Disney-style storytelling applied to science. No, Newton didn't have a light bulb moment because an apple smashed into his skull like divine punishment. It was a metaphor, then a rumor, and now a pop legend. Newton developed his theory over years, and he never wrote about a revelation-producing bump. But hey, it sounds cuter than saying he just thought a lot. If you take off your helmet in space, you explode. Ha! Boom. Nope. Hollywood messing things up again. If you take off your helmet in the vacuum of space, you don't explode like a mutant popcorn. You pass out in about 15 seconds, you freeze, burn, or dehydrate depending on where you are. But your body doesn't burst into 1,000 pieces like an intergalactic piñata. Sure, it'll be rough, but with style. The full moon makes us crazy. How convenient. Who doesn't love blaming the moon for acting weird? Sorry, but neither science, psychologists, nor hospitals have ever found a link between full moons and outbreaks of madness. No werewolves, no extra births, no rage attacks, just extra light and romantic excuses. Gravity is a force, and also, it's not. Now we enter advanced level. According to Newton, yes, it's a force. According to Einstein, nope, it's the curvature of space-time caused by mass. So, Earth doesn't pull you like a bored magnet. It bends space like a sagging mattress, and you, poor thing, fall toward it like a little ball spiraling down. Quantum physics, with extra drama. The Big Bang was an explosion. In your dreams. Ah, yes, the famous Big Bang. Everyone imagines cosmic fireworks, with planets flying through the air and a dramatic narrator saying, "It all began with an explosion." False. There was neither a spark nor a sound. It was a silent expansion of space-time from a point smaller than your Monday morning patience. Explosion, as in actual explosion. Nope. Mars is red, or orange, or sometimes gray. Another myth with branding. The red planet is as red as tomato sauce with an Instagram filter. In reality, Mars has grayish, brownish, and yes, some reddish tones due to rust. But the red planet label is more marketing than scientific accuracy. Thanks, NASA, for over-editing photos like a low self-esteem influencer. The Milky Way is made of milk. Sure, and the moon is cheese. If you thought we were swimming in a sea of cosmic milk, sorry. Milky Way comes from the Latin Via Lactea, because the Greeks fancied themselves poets even when stargazing. In reality, it's full of gas, dust, stars, black holes, and attention alcohol. Yes, methanol clouds the size of your ego, but not a single drop of calcium. The universe is black, but it can also be beige, according to chic science. Black? How basic. A team from Johns Hopkins University analyzed the average color of the universe and found out it's beige, like coffee with milk. Who would have thought the entire cosmos had the soul of a minimalist lounge? So next time you stare at the sky and get all existential, remember, you're surrounded by the most boring shade in the Pantone catalog. The asteroid belt is a death trap. In movies, maybe. In films, asteroids are so crammed together you need ninja reflexes to dodge them. But in real life, they're millions of kilometers apart. Flying through the asteroid belt is duller than a neighborhood committee meeting. Nothing happens. The chances of hitting one are nearly zero unless you're extremely clumsy, or extremely unlucky. Black holes are space vacuums, like your mom on Sundays. Hollywood paints them as all-devouring beasts, but black holes aren't out there sucking up matter like maniacs. In reality, they behave like any other celestial body, just with a more intense diet. Their gravity is strong, yes, but they're not out hunting planets like cosmic snacks. If you get too close, sure you might get swallowed in terror, but no, it's not a space Dyson. A nuclear bomb would destroy an asteroid, only during the end credits. Let's drop a bomb and save the Earth. Sounds familiar? Of course, because you've watched too many movies. The truth is, a bomb would barely scratch the surface of a large asteroid. And worse, the fragments would still come toward us like cosmic shrapnel. So instead of one big hit, we get a meteor shower of problems. Thanks for nothing, Hollywood. Jupiter orbits the Sunday, but not as submissively as you were told. The uncomfortable truth. Jupiter is so massive it doesn't orbit the Sun like a simple follower. Both orbit a common center of gravity that's actually outside the Sunday. Yep, like a couple that can't stand each other but still dance out of obligation. Jupiter doesn't orbit. Jupiter sets the terms. Climate change is a conspiracy. Sure, and the Sun revolves around the Earth. Some still believe climate change is an invention to sell solar panels. But science has spoken. We're the ones causing it with our brilliant ideas like constantly burning stuff. Since the Industrial Revolution, we haven't stopped heating up the planet. And while some are just now realizing the poles are melting, there are still people who blame the sun or the penguins. The pyramids were built by aliens. Or by people with neurons you call. This is the favorite insult to human intelligence. How could they build them without cranes or Wi-Fi? Easy, with ingenuity, patience, and full-time slavery. The ancients knew how to wet the sand, move stones, use pulleys. But sure, it's easier to say aliens came with telekinesis. Less Discovery Channel, more common sense. And that's a wrap on the 20 astronomical lies you probably believed for years. If any of them blew your mind like a supernova, subscribe to Flip Out Space, hit the bell, and tell us, what other cosmic nonsense should we destroy with style? See you next time, if the asteroid belt lets us.